Hi, everyone, and welcome to the One Lab 2021 Summer Studios Information Session. Thank you for taking time today to zoom in from all over to learn about our program, to meet faculty and TAs, and understand why One Lab is such a unique and special program. I'm Vivian Kwan, Executive Director of Terreform One, a 501c3 architecture and urban design think tank that's dedicated to improving the environment through research, design, public art, and education programs, such as the One Lab. If there's one way to invest in the future of our planet, it's through educating the next generation of design and environmental leaders. You'll hear from these speakers today. Maria Ailova, Chair of One Lab, Terreform One co-founder, an architect, educator, and inventor holding 18 patents. Maria is the former academic director for the education group CIEE and the former leader for Arab University in the Americas. She was recently awarded Woman of the Decade in Science and Design Leadership at the Women Economic Forum. Next, Julie Bliha, an educator and program administrator, is a native New Yorker with Montana roots, where her fascination with the green design was sparked by the sod roof house on her family's homestead. In her former role as assistant director, Julie helped launch the pre-college program at the School of the New York Times, helping to design and run everything from curriculum development, hiring teachers and industry leaders, and proudly supported the Diversity, Equity, and Inclusion Initiative there. Dr. Nina Anker, faculty for architecture and the environment, founder of NEA Studio, award-winning architect, educator, furniture and lighting designer, specializing in sustainable design. Dr. Mitchell Joachim, faculty for biodesign and engineering, associate professor at NYU, co-founder of Terreform One, and senior TED fellow. Mitch is a globally recognized leader in ecological design and urbanism, with a CV that would take the better part of this info session to unpack. And finally, Amelia Mann, our sustainable fashion TA and dual degree candidate, studying material engineering from Brown and fashion at RISD. So I'm also going to share with you a little bit about our agenda. So Maria will be introducing and explaining all about our summer studio, followed by faculty and TAs, Nina, Mitch, and Amelia, who will talk about the architecture and the environment course, the biodesign and engineering, and the sustainable fashion. We also will have a special preview of our unboxing of Studio in a Box, followed by Julie Bliha, our director of One Lab, who will tell us all the information you really want to know about how to apply and program details. Finally, we'll have a live Q&A. Now, if you have any questions throughout the presentation, we encourage you to write your questions into the chat box, and someone will be answering them as we go. And we also will be taking live questions at the end. Next. So just to give you a little background on Terreform, as I mentioned before, we're a nonprofit urban design and architecture research group. We endeavor to combat the extinction of planetary species through pioneering acts of design. Our vision, Design Against Extinction, incorporates all species, including humans. And what's reflected in our work, which aims to illuminate the environmental possibilities of habitats, cities, and landscapes across the globe. Here's our studio, where One Lab takes its inspiration. We're located in the Navy Yard, inside the old former machine shop, of the Navy Yard, which is now transformed into the new lab. We were the founding members of the new lab, which is a collective space for engineers, makers, and socially minded entrepreneurs. Finally, we have here just an example of a recent competition project. We were one of the winners for part of a TED sustainability global event called the Global Countdown, where people were challenged with presenting and coming up with a vision for a solution to the climate crisis. In our proposal, which we built and fabricated at the Navy Yard, this egg-like structure called the Anti-Extinction Library is conceived to hold and preserve samples of DNA of species that have already gone extinct or about to go extinct, with the hope of one day being able to resurrect them. And on that note, I'm going to turn the mic over to Maria. Thank you.
Hello, everyone, and welcome to our info session. I'm calling you today from New Lab, and our studio is right around the corner. And today I'll tell you a little bit about the history of One Lab and then talk about One Lab Summer Studio 2021. One Lab began as this extraordinary think and do tank of architects, engineers, artists, biologists, designers, and all different professionals that came together to think about alternatives to traditional forms of teaching and professional practice. And in 2009, we started a new profession. Urbaneers are these multidisciplinary professionals whose job is to regenerate, pioneer, and sustain the future urban realm. People often ask us, who is your perfect urbaneer? And we tell this story. Imagine if we take from Jane Jacobs, who was an ecologist and economist, her a keen sense of community, and mix that with Robert Moses. He's a planner and a visionary, but also kind of somebody with a brute political force. And that ideal urbaneer would be someone like Frederick Law Olmsted, who's a landscape architect and designer of Central Park in New York City, among many other parks. The profession of urbaneering, it's not reserved just for architects, designers, planners, or politicians, but biologists, farmers, teachers, chefs, artists, they all should be involved in designing the city of the future. So in 2009, we started the One Lab summer program, and we put a call to action, and people came from around the world to experiment with us, learning the principles of synthetic biology and how to grow materials out from microorganisms, building full-scale prototypes, and working with living materials. Here, the students are pleaching trees together to create a living wall that, when it's fully established, can withstand lateral forces. We also did a lot of experiments with green roofs and the principles of phytoremediation. Here, the students build this unit that it's using wetland grasses and has the ability to filter gray water. And I would like to define the field of biodesign that incorporates living organism as an essential component, enhancing the function of the finished work. So this is not biomimicry. We're not mimicking nature. We're actually working with living organisms. And that leads me to One Lab Summer Studio 2021. We created this program to help you discover the future of design and technology, sharpen your problem-solving skills, propel your academic career, and get ready for college. So this is a 2-week summer program that consists of lectures, virtual tours, and design studios. And we will be taught by online by award-winning faculty carefully selected by Terreform One. And just to give you a sense of who they are, they're a mixture from biologists and artists and technologists and astrophysicists. They all bring a different perspective to you. And more than 50% of them are TED speakers and TED fellows, and you'll have this unique opportunity to be with them in a small class, average of 12 people, and engage by asking questions and having a discussion. And we've asked our faculty not just to give a typical presentation, but to talk about their career path, the choices they've made, and how they got where they are. We'll have 3 different courses that we'll offer throughout the summer. In the architecture and the environment course, you'll learn how we can change and mitigate the damage that the building industry is causing today. Buildings and their maintenance contribute 40% of all the greenhouse gas emission. And we want to turn that to 0 and make a positive impact on the environment. In the biodesign and engineering course, you'll learn how to grow materials from microorganisms in an ecologically sustainable way instead of polluting the environment. And finally, in the sustainable fashion and materials course, you'll learn about the advances of fashion technology, incorporating new type of materials, but also using new socially responsible labor practices. But most importantly, you join the call for youth climate activism and become part of that community. Climate education is most powerful when it makes you passionate. And that's our goal for summer 2021. This is Alexandria Villaseñor. She's one of the most amazing young women I've recently met, and she's part of the youth climate movement. And I've asked her to come and speak to us, so hopefully she'll be able to stop a few times and talk to you over the summer. So what is a typical day at One Lab? We'll start in the morning with a lecture. And as I said, you'll have a chance to engage in a discussion and ask questions. And then we'll leave you a few minutes for reflections where you're taking notes in your sketchbook. After that, we'll take you in a virtual tour that will be really connected to what you've just learned in the lecture. So you'll have this unprecedented access to the designer studios, to biological laboratories, and to factories that, because we're doing this virtually, we'll be able to take you inside into places where typically visitors are not allowed. In the afternoon, you'll be working on your studio projects, supervised by both the instructors and visiting faculty, and you have a chance to get away from the screen, go outside and do few hands-on experiments. So here I just have a little bit of more detailed example. Imagine a day, this example, it's a day of the sustainable fashion and materials course. You'll start with talking to Dr. Amanda Parks, who is a fashion scientist who is currently serving as the Chief Innovation Officer of Pangaea, which is a material science brand. She'll tell you about t-shirts that are made out of seaweed rather than cotton, puff jackets filled with wildflowers rather than down, and sneakers made out of grape leather rather than animal leather. You'll learn about clean water technologies that they're using to make sustainable fashion. After that, for the virtual tour, we'll take you to the London studio of Pangaea, and you'll see how they are growing these new materials and processing them in their laboratory. And after that, we'll take you to Portugal, where they are manufacturing these new sustainable fabrics. And in the afternoon, you'll be working with your studio in a box. Every student in all 3 courses will receive a version of this box. And I don't want to steal the thunder from Amelia, who will do the unboxing a little bit later, but you'll have all the materials necessary, including the Terreform 1 book, Design with Life, that we'll use as a textbook, and you'll be able to see all these different examples of biomaterials and technologies inside. And most importantly, during the studio time, you'll be working on the studio projects that will be part of your portfolio. And you'll present your work at the last day of the class to a jury from the faculty members. So here are a few examples. For the architecture in the environment course, you'll learn how to sketch and also how to make simple 3-dimensional models and create typical drawings that you include in your portfolio. For the biomaterials course, you'll learn how to grow materials, in this case from mycelium. This will be provided to you in your studio in a box, and within the 2 weeks, you'll see that process. And in the sustainable fashion and materials course, you similarly will have materials that you'll be growing new analogous leather in this case, and creating your own designs and actually fabricating certain products. And you'll also have time to go outside. We'll have simple assignments when we'll send you out to sketch and paint and generate certain ideas for your future project. And I want to say that all 3 courses are designed for beginners. It will teach you all the skills that you need, and we will provide all the materials to make this experience really fulfilling. So don't worry, we have great faculty and great instructors who will be able to work with you, provide one-on-one experience, and to make you successfully complete these 2 weeks. And with that, I'd like to invite Dr. Nina Anker to talk about her work and tell you a little bit more about sustainable architecture.
Excellent. Very nice to meet you all. I'm Nina Edwards Anker. I'm design director at Terreform 1. I'm an architectural designer. I teach environmental design, and I'm going to introduce this class. I'm going to share my screen. Great. So I run a studio called NEA Studio. And we are sharing space with Terreform 1. We've been neighbors for many years and collaborated. And our firm just finished an environmental house Gold LEED certified that just won the AIA Long Island chapter award for sustainable design. And I was going to introduce this house as a way of addressing and explaining what some of the principles that the students will be learning to address environmental design as an example. We'll be looking at many examples, but for example, one main principle is having a thick northern back wall and a solar passive gained front facade facing south. So they will learn how a house can be based, or a building structure can be based on very basic passive house principles, which is to be facing south and then gathering thermal mass on the north. And then principles such as rainwater collection and solar power collection for an electrically powered structure. They will be learning principles such as how to draw the sun path for the solar power collection passively, as well as the prevailing breeze. And they will learn to just draw a simple site plan where they have the north sign indicating orientation. They will be aware of how how structures can relate to wetlands and the landscape in which they're placed, how to create a palette of materials that are native planting and permeable paving and local organic materials and how that can speak to local culture, but also LEED certification. And also experiences through structures, such as how solar energy can relate to the experience of the house through perception of color and temperature, notions of architectural design as to how we can relate environmental principles of rainwater collection and irrigation through reflection, and how reflection on the horizontal and vertical planes can bounce off one another to open up the boundary between inside and outside, and how all of these tools that we can learn are about connecting us to nature, and also to understand what it is to develop a LEED certified palette of materials, which are all local, organic, and derived from within 500 miles distance, like this Vermont marble, and then these prefabricated trusses, which is a new technology for prefabricating timber, which is better for the lungs than cement, and in installations in structures as well at the smaller scale, where solar power can illuminate the interior. This is 2 solar chandeliers made of photovoltaic modules. And then, for example, the fireplaces that are used in environmental structures, what type of fireplaces are allowed, because the whole principle behind eco building is to not allow air in and out too much. And then all the organic materials, again, used for the furnitures. And then how can this relate to different climates? For example, in a tropical climate where you have the monsoon, what type of structure would you have in different climates to address the geography? And then there's going to be an emphasis in model making with hand model making, and playing with organic materials. We're going to look at public park installations that use solar power, such as this bench in the shape of the Big Dipper, where they will learn the basics of electrical engineering, and they'll understand how solar power can work, and they'll make their own solar lights, such as these, where for example, this design uses the idea that the solar panel will tilt according to latitude at different angles to get optimal annual solar power collection. And they will learn how to understand this module and how it can work within their designs and play against different materials, such as organic seaweed, or whatever they find that they would like to play with in terms of how different organic materials can filter light. So that's it for now. And of course, the end goal here is for the students to build up a portfolio which can show through the designs that they make and through some of their drawings, their understanding of environmental principles and how this can help them get a head up when they're doing their college applications as well.
Thank you, Nina.
Thank you.
Next, I'm going to invite Dr. Mitchell Joachim, who is going to talk to you about biodesign and engineering.
Hi, does everyone see me okay?
Yes, we can see you.
Oh, great. So I would like to talk to you today about what we've been doing at Terreform 1 and New Lab for the last 14 or 15 years. A lot of this has to do with really understanding this nascent field of, I guess, living systems incorporated in what we would say are essentially bioengineering. So a lot of this work comes from an alignment with Dr. Oliver Medvedik, who is now the head of the Kembar Center for Bioengineering at Cooper Union. And I guess for some time, we have been thinking about how we can actually improve thinking about our environment by no longer using concrete, glass, or steel. So some of the, let me see if I could switch to this. Yeah, here we go. So one of the things that we've been looking at was Mycelium, which is essentially the root base of a mushroom. In this case, we're using reishi. It's a dendritic structure. The roots spread out and they interweave with one another to form this dense matrix or lattice. This is a good image of what that's like. And this is a system that occurs naturally all the time. You can find this on forest floors, sides of trees, etc. What we do here in this slide is that we propagate the mycelium over the course of 7 days. We acculturate it in a petri dish with the right alluvium, essentially give it the right food, which is in a lot of cases waste materials, agricultural waste materials such as wood chips or cotton husks. And in 7 days, the material is absolutely devoured by the root base of the mushroom and forms this kind of dry insulation-like material called mycelium. It could be used for a number of things. Here, in the next slide, we were combining it with Acetobacter, which is a bacteria-expressed cellulose, to make it more hydrophobic. And these two materials combined together actually allow it to be anything from, in this case, a chair. This is what we're showing here, is a chair that instead of producing a chair that we do with the industrial methods, which is modular systems made from plastics and steels and are essentially designed to be thrown out or end up in a landfill. Here's a chair that you can eat. It's fully grown in a lab. It's absolutely organic. It's compostable. Next slide, you can see these two materials fitted on top of one another, the mycelium and the Acetobacter. And we're going to show you guys how to do this, how to grow these materials in anything from a bathtub to your kit at home, and then produce things like this. Next slide, which is a simple structure. This is a chair made out of a number of molds that take almost any shape. And this is kind of exciting because when you're done with something like this, you throw it into a garden and it feeds thousands of other forms of life. So in this slide here is my older daughter sitting on this chair designed for her kindergarten, so she could tell her parents that the chairs in school are designed to fit to the planet's metabolism. She probably wouldn't use the word metabolism, but she would say they're designed for the earth, and that they're just like her crayons and her glue. You could eat them, although you probably don't want to. And we did larger ones in this slide, which is essentially a bamboo ply made from profiles. So we use parametric models, which is a simple way of drawing in 2D, and then augmenting that 2D over a series of planes to get a complex curve shape, which in this case makes more of a bench for adults. And then that bamboo, next slide, is printed and connected together. The system is woven together. And then we add the mushroom material on it, the mycelium. We let it grow for 7 days. We apply a little bit of heat and essentially petrify it. And you get a chair made out of bamboo and fused with mushrooms that is like nothing you've ever seen before. And this teaches us all kinds of things about geometry, about using different tools such as the laser cutter or a CNC mill. It also teaches us how to grow things. We probably won't do something this large, but it'll be something that you can definitely do at home and then extrapolate that to bigger systems. And then the second thing I want to show that's very much about bioengineering or engineered living materials is it goes to the core of the work that we're involved in. It's called the Monarch Sanctuary. And this is designing against extinction. This is stopping this kind of, this endless amounts of resource extraction we see on this planet, and the kind of sort of atmosphere that we're in now that is affecting almost every organism, from corals to insects to birds to every kind of mammal on this planet. Something that we are deeply worried about is more and more extinction. So we have surpassed any normal acceptable background rate of extinction to the point of some of the most beautiful creatures on Earth are disappearing. So the Monarch Sanctuary is looking at saving this guy from oblivion. It's the monarch butterfly. We've lost around 90 million of these guys in the last few years. The US Fish and Wildlife Services are saying they are near endangered and not extinct yet, but they're getting there. So we developed a system that respects these butterflies because they're native to New York. And here you can see on this map, they actually move from New York City over generations all the way to Mexico, where they reproduce, and then go back 4 generations later, where they're supposed to thrive. Unfortunately, all the habitat between Mexico and New York has been essentially whittled away. They really require milkweed to survive, to lay eggs for the caterpillar stage and the chrysalis stage, and that is essentially gone. So next slide, we have produced a building type where in the skin of the building, we have designed everything for the life cycle of monarchs. This is what we call a vertical biotope mosaic. There's a mosaic of different habitats that are essentially added to the building in sequence. They extend vertically and they care for the entire life of the monarch. Everything from when it reproduces to actually making it porous so it can go in and out, to areas for where it sleeps, to things that it eats, etc. So here on this slide, you can see the different stages of the monarch butterfly, from its egg laying stage to the caterpillar and the milkweed, all the way to the final adult butterfly that is meant to repopulate the area. This building section shows that humans are on the inside and the butterflies are in the in-between space between the outside wall and the kind of this in-between, what we call interstitial wall. And there is this vertical landscape that has all different kinds of plants and areas for the butterflies to thrive in, including algae-based windows. Next slide. The air circulates inside. It's actually, in some ways, scrubs the air, because this is an entire system that deals with the exchange of indoor and outdoor air. And in some levels, as it moves through this biodiverse microregion, cleans it. So it's great for the office workers on the inside. Next slide, you could see the amount of CO2 that comes in and the oxygen that gets produced, and then it's released and then exchanged inside that plenum space. Next slide shows that the entire building itself is predicated not only on the butterflies, but a logical optimized exchange of energy and sunlight and ventilation systems throughout the entire structure, especially through the core. Next slide, this is showing the different feeder systems. We have milkweed hanging from these large racks, and then other areas that are more aqueous-based, where they feed from these sacs, which are essentially an electrolyte fluid similar to Gatorade. And this is what they love to drink. And the butterflies here enjoy life to its fullest. Next slide, see a detail of some of these artificial flowers, the electrolyte sacs, and the milkweed areas in this mosaic structure. A modicum of maintenance is all that's needed for a gardener to come in and actually take care of all of these systems. Next slide, we built a 4-ton version of this system. That was in the Smithsonian Cooper Hewitt. So the live monarchs were inside this structure where they were thriving in this biodiverse environment. And here is another set of images showing you this, mock-up, if you will, of the facade system functioning. Next slide. It's a double skin made of a dye grid on the exterior, and then all types of plantings, not only for the butterflies, but anything to increase biodiversity in cities. Next slide. So here you could see that these are the early designs for some of the concrete work. The concrete will last anywhere from 200 to 250 years, and it's got areas for mud baths for butterflies, areas for respite, and areas for drinking. Next slide. All of these kinds of concrete panels and aperture points get fitted inside the facade. They are essentially in service to the butterflies to keep them happy, but also in service to all different types of plants. Next slide, so you can see some of the nectar feeder areas, both artificial and real plants together alongside the butterflies and fitted into this concrete system. The concrete is a low embodied energy concrete. So it actually contains fly ash. It produces a minimum amount of carbon and is structural. And next slide shows that all of it together. And next slide there is our monarch butterfly friends enjoying that in-between space in this particular building. So that's just some of the work that we'll be doing and talking about there at the One Lab School. And I'll be one of the faculty members and more than happy to answer a number of questions. Thanks very much.
Thanks, Mitch. This was very exciting. We hope to see the building in New York one day soon. I'm going to invite now Amelia Mann. She is the TA for the Sustainable Fashion and Materials course, and she will first tell us a little bit about her work and then do the unboxing of Studio in a Box demo.
Hi, so I'm Amelia Mann, and I'm going to be the teaching assistant for the Sustainable Fashion and Materials course. I am currently a senior studying material engineering at Brown University and apparel design at the Rhode Island School of Design. And my work is primarily in the intersection of biology, technology, and the garment industry. So I'm really interested in this intersection because the garment industry has a huge problem in regards to sustainability, from the exploited labor and land that is used to make textiles, from the petroleum that goes into textiles and dyes, which then pollute water and also consume huge amounts of water, to the waste that's produced at almost every single step of the process, from construction to end life. There's just a host of problems on every level. But I believe that through biology and technology, we can develop ways to not only recycle and reclaim already existing materials, but also create new sustainable materials and methods of creations. I also really think that they will challenge us to ask the question of how our clothes and the textiles they're made of can go beyond what they already do and better interact with our bodies and the environment around us. So I'm going to just very briefly talk about some of the most recent projects I've been involved in. So I was working at the NASA Soft Goods Lab. One of the projects I was working on was the microgravity sock. And the main problem that this was trying to solve was that when you're in space, you use your feet kind of like your hands. So they're often rubbed raw from gripping underneath things. They also lose all the calluses off the bottom of your feet because gravity is not acting on them in the same way. And there's also just a host of problems that go into designing for space, from how you clean things and how you store things. I worked really closely with astronaut Don Pettit to make sure that the sock I was designing addressed all of their issues. And I just included this fun image because he actually was a lover of design and designed the microgravity coffee cup. So this was the final solution that I ended up proposing. So I utilized 3D knitting kind of to create specialized structures in specific locations. So on the top of the foot, I had kind of like a padded structure for cushioning. I utilized looser and tighter knits in specific areas to give structure and to optimize airflow through the sock. And then I also kind of created a ridge structure on the heel to so when you pulled the sock off, it would scrape your dry skin into the sock instead of releasing it into a cloud around you in the microgravity environment. The other project I worked on was the Artemis collection, which was a series of garments for the next mission to the moon, which is the Artemis mission. And basically the challenge here was to update from the Apollo garments, which was a cotton jumpsuit and a Teflon jacket and pants that they wore for 7 days straight, which was really not going to cut it for the Artemis missions, given that they're almost 3 times as long. And there's also a host of other kind of challenges they'll be enduring. So there are quite a few design details that go into this, and I was just going to highlight some of my favorite solutions I ended up using. So one thing that I was really concerned about was that, when you design clothes on the Earth, you're often kind of thinking about the body in the standing position. But when you're in space, you're actually in what's called the neutral body posture, which is midway between a sit and a stand. So I really looked towards actually wheelchair pant design to kind of see what strategies they employ to make the pants more comfortable for sitting for long periods of time. I also utilized 3D knitting again to kind of create padded structures in what's called the pinch point areas, which is basically where your body can hit the walls around you because you're floating instead of just standing in place. And then I also ended up designing a tool bag for them to be able to store their tools in so that they aren't floating off, but I wanted it to be kind of also easy to take off in case of emergency situations. And this is just the final lineup of how everything came out looking. And then also I wanted to highlight some of my work with biomaterials, since that will be a big focus in the fashion and sustainability course. And here I just wanted to demonstrate how I was able to take bacterial cellulose and kind of, when it was wet, and mold it into a vase shape and then just dry it in that shape. And I'm really looking forward to TAing this course. You know, when I was applying to colleges, I didn't really have a really strong sense of that, you know, art, design, and science could all exist in this field together, and there were careers and opportunities that way. So I'm super excited that that's being presented earlier to a younger host of students. And also for the opportunity to work with you on these projects, because I know not always like art schools have the, or high schools have the capacities for art projects like this. So just really excited to be for this summer. And now, okay. Now I'm going to be demonstrating the studio in a box. So I have it here. This is our current prototype of the box. This one's for the Sustainable Fashion and Materials course. So here, I'll hold it up for you to see the outside of the box. This is what it would look like. Then we'll do a very quick camera change. All right, there we go. So for this course, there will be 2 projects. The first will be kind of the development of a material library of biomaterials. So this is like on the inside. So during this course, we'll show you how to make biomaterials using everyday household like organic byproducts such as banana peels, and how to make biomaterials from that by combining them with a few of our specialized ingredients like glycerin and these molds. And some examples of what that might look like. You could make like a coffee ground based bioplastic, or perhaps a composite with oats. And the main purpose behind this project is twofold. One, to like show you how biomaterials are made and the science behind that. And then 2, to provide you with a resource that you can use for your future projects, or if you wanted to run workshops for your peers. The second project will be a sewing project. So we'll be sending you some pre-made biomaterials and then some basic sewing tools. This could be like a wallet or a cell phone case or something else of your design. And throughout the course, we'll be showing you how to draft, pattern, and sew through live demonstrations and also written instructions. We'll also be demonstrating some of the latest 3D modeling and manufacturing software that's used in the garment industry. And the main purpose behind this project is to get you familiar not only with making, but making with biomaterials. And then throughout the course, you'll be attending daily guest lectures and virtual studio tours. So we've provided here a notebook for you to take notes on these different activities and also the discussions we'll host around them. Here's just an example of what that might look like. And also this will serve as a place for you to sketch out ideas for your projects. Just a little collage. And last but not least, you will also receive a copy of Terreform 1's Design with Life, which will serve as inspiration throughout the course and also beyond. Yeah. Yeah. And so that will conclude the demonstration of the prototype of the studio in the box.
Thank you, Amelia. This is very exciting. And we have one more presentation left before we go to questions and answers. And I'll invite Julie Blecha to tell us a little bit more about the details of the program.
All right. Hi, everyone. I agree with Maria that I want to take Amelia's class. Anyway, we're going to begin our program overview with a look at the course days, dates, and times. So 1 second, and I'll go back to how. So we have 4 two-week sessions throughout June, July, and August, and students can enroll in more than one session. That is, all 3 classes are offered during every session. So if for some reason you're so excited by 2 of the classes, we would love to have you come back. As Maria mentioned, the class size average is 12, maximum we're setting at 15 to make sure that everybody gets a great experience from it. All courses meet Monday through Thursday, 11:30 to 4:30, and there's a lunch break from 1:30 to 2:30. And please note those hours are Eastern time. And you can see the session dates below. at the bottom of the slide, just to point out that there is no class. We put in a break between sessions 1 and 2 for the July 4th holiday. Okay, so here's a calendar. And again, I'm reiterating some of the things that Maria and indeed Amelia have touched upon, but we thought it would be helpful to see this visually. So you will note that the first Monday, we actually start with the tech check 30 minutes before the start of the instruction period. That's so we can make sure that everybody's connected, ready to go. You have all your materials ready to go. And we will have a tech person on staff to help troubleshoot. And then you will also note that the final Thursday is given over entirely to project work and final presentation. So we, and I will talk a little bit more about the interaction between students and faculty. I know some of you were curious about that. That is coming. So next we have eligibility and applying. The program's open to those who will be rising 10th through 12th grade high school students, as well as graduating seniors as of the first session in June. And in order to apply at our website, onelab.org, you would select the session that you want and then list your course preferences. And we're asking that you list, if you have one that you really want to do, go ahead and list a second and third preference in case your first choice is already filled up. So you will also answer some short essay questions. And this is also the time that you would apply for financial aid if you're going to do that. So to move on, let's talk about tuition. So each class is $1,600 plus a $50 materials fee, and that covers the studio in the box that Amelia just demonstrated, and a $50 non-refundable application fee. There are multiple ways to earn a discount, although there is one per family. One, you can enroll in multiple terms, like I suggested before, and if that were the case, you would get a 10% tuition discount. You might register with a sibling or refer a friend. That would get you a 10% discount. The best offer we have going is getting a 10% discount for early bird registration. So you apply by March 31st and pay by April 15. But what's even better than that is, in addition to that, is that you also would get 2 one-hour portfolio review sessions, one-on-one with our faculty, and that's a value of $200. And once you meet our faculty, or you've already seen a little bit of it, you know what a great, great bargain that is. I should say value. And you would be booking this after the course completion, and we will allow some time, a couple of months, for you to book the 2 sessions. Again, only one type of discount per person. Okay, so now we're going to look at 2 slides on daily activities, and this is the nuts and bolts of the course. So we have what each day entails. Again, I'm reiterating, we're reinforcing some of what Maria said, but we want to be very clear on the nature of the relationship between faculty and students. So as you heard, it's an online program for the most part. So we will have 1 instructor and 1 TA per class who are with the students every single day from the start of the day to the end of the day. The morning is the time for the daily special guest who will hold a lecture and then a Q&A with the students. And then also, as Maria explained, that would be the time to do the virtual tours, site visits. And then in the studio time in the afternoon, you have another visiting lecturer. Now, what I want to say about this, the instructor and TA who are with the students all day long, they are really important. They are the ones who are going to be working with the students to look at the interdisciplinary nature of the program, to create a narrative and a spine for themselves, to make sense, to figure out where they want their further inquiries to take them. They're the ones who will help discuss and link the different guests who have come to speak. And as Amelia so wonderfully demonstrated, the TAs are every bit as engaged with the generation of ideas and the honing of practice. So we are very lucky to have 2 teaching staff there with the students all day long. And the other thing, again, I want to reiterate is the outdoor project work. And that is an opportunity for the students to work independently That is, they go off on their own, and then they have the resources of the world around them, the surrounding landscape, structures, people to sketch, take inspiration from. And this is a very important and integral complement to the student-faculty interaction and project work. They come back with all sorts of ideas. And the idea, the last thing I want to say about the studio time is that the instructor and the TA, and if there's a guest lecturer in the afternoon, they will be available on the online connection all afternoon. Students can go off and work by themselves, and then they can come back and check in if they have questions or they need guidance. So they can spend as much time or as little time as necessary in that studio section of the day. Okay, so next we're going to have the daily activities 2. And this will focus again more on the student's experience. As we saw, they'll have materials delivered in a custom prepared studio in a box. And I really want to highlight the uniqueness of this. I don't know of any other program that does this. And we sort of take delight in being able to design a box for students in a design program. So this is something of a bespoke service that we're really happy to provide to the students. So again, online faculty will provide oversight while the students focus on their hands-on studio project. And then at the end of each day, everybody reconvenes, even if they were off outside or off doing their work, and there will be a discussion led by the faculty so that the students are able to look at the day holistically, or in fact, look at the preceding days holistically, and that sets themselves up for the following day. Okay, I want to move on now to discuss the goals and process of our financial aid program. So at the heart of Terreform 101 Lab's mission is the desire to build a more environmentally conscious and equitable world. And to do that, we need a variety of backgrounds, experiences, and voices in the classroom and the studio. So to that end, we offer a limited number of need-based awards. And I have to stress it is limited. We definitely want to grow our ability to offer sponsorship, but at the moment, we will have to limit that. What we are doing is when you apply for financial aid, you will write a statement of need. It's just a one-page brief essay noting the amount you're requesting, and you can request a 10 to 25% discount, and you will send along supporting documentation. The majority of the awards are those types, the partial tuition remission. We will have a very small number reserved for full scholarship students. That is, those students who would not be able to attend at all if they were not awarded the full scholarship. And we will confirm the amount that the student is awarded when they're notified of their acceptance to the program. I also want to add, aside from any financial aid that we're able to offer, I have managed programs where students have done amazing things. They've gone and looked for their own grants from faith-based or community-based organizations. They've done GoFundMe's. There's a variety of way that they have been able to help themselves. We realize, again, that's not possible for everybody, but we definitely want to be inclusive in our work towards a more environmentally conscious and equitable world. Okay, so finally, I want to note that this is a very text-heavy page. This is a very dense, heavy page. We don't normally do this in design. We try to let the images and speak concisely and let the images speak. But there's so many takeaways. I wanted to make sure that you could all see them on the screen in front of you. As I mentioned, if you register with the early bird, you get the discount and the 2 one-on-one portfolio review sessions. You get, as Nina mentioned earlier, each course gives a student evaluation and a design portfolio. You can definitely use them as college application supporting materials. If you're already applying for grants, that's also great. But also, as Maria pointed out, this is all about climate activism. So you get membership in a community of like-minded peers. We know that youth activism is driving so many changes in our society today, and climate activism is not the least among them. So this is one way for you to connect with those people and, in fact, take your activism to a new level. You also get, as Maria mentioned, introduction to prominent figures in cutting edge architecture, biodesign and fashion. And then academically, the two skills that you're going to take away are learning how to imaginatively conceptualize projects and then move on to practical execution. It's a really highly valued skill, prized in diverse career and job pathways. Certainly something that gives you a leg up when you start your college studies. And then the other thing that you are doing, learning, is digging deep into the process of design innovation. So you're connecting concepts and practices that might not be immediately obvious, connecting those dots, and suggesting prototypes, iterating and reiterating design until desired outcomes are achieved, or maybe even just further identified. But what we want you to take away is the ability for you to think that you can do anything because you're starting at square one and you have the passion and the commitment to do that with our help and mentorship. So you can help lead the charge against climate extinction, make a positive impact on the world. So we hope you join us at One Lab Summer Studio 2021.